Let's see. All right, I hope we are online now. So hello everyone and welcome. In this live stream, we'll be going over the fundamentals of fish networking, okay? By fundamentals, I mean stuff like SyncVars, sync lists, broadcasts, RPCs, and so on, okay? The reason I'm trying to do this is because a lot of people seem to not understand the concept of concepts of SyncVars, sync lists, sync dictionaries, broadcasts, RPCs, and so on. So hopefully in this live stream we'll explain them well, okay? And I will show some examples of when to use what, and I'm going to show some tips and tricks that I usually use myself. So I hope you'll enjoy the stream. Oh, hello Rectangle, how are you doing? And hello Wiglord, and hello Brandon Anderson. Welcome everyone to the stream. Just before I continue on, I would like to ask a question. Is my voice sounding good? Like, is it too low or too high? So I'm going to assume that it's okay now. So we have a message from Wiglord, says, sync objects is new to me, looking forward to learning about VARs too. Voice is good. Oh, thank you. So sync objects are quite complicated, okay? Not like hard or anything, but they could take a bit of time. So I will see if we can take a look at them at the end of the video, because they require a lot of explanations. Sorry, at the end of the stream, because they require lots of explanations and stuff like this, okay? So let's stick to the important stuff, okay? So I went ahead and created my usual Unity scaffold. That is an empty project with all the packages removed except for Fish Networking and TextMesh Pro and the Visual Studio package. I have a couple of scenes, scene 1 and scene 2. Both have a camera. And I created a network GUI script here that simply allows me to start and stop the server quickly, okay? I have recently made a stream on network multiplayer UI management. You can check it out. I will link it soon in the description after the stream ends, or I could message it during the stream, okay? So the first thing we're going to get started with are SyncVars, okay? We're going to go to the documentation here. And basically what SyncVars are, they are like network variables. That's literally their name, okay? They allow you to conveniently sync values between the client and the server without having to send RPCs or use broadcasts or anything, okay? So they're basically a convenience feature. They have their downsides sometimes, and I'll explain them, but they usually should be the first go-to solution for your synchronizing names or scores or stuff like this, okay? So I'm going to show a basic example of a SyncVar, okay? Let's go ahead and create a new script, and I'm going to call it player. We'll open it up in Visual Studio. Oh, hello, my class. Sorry, I didn't notice your message earlier. Okay. So now, inside our player script, I'm going to usually, do like I do usually. I'm going to seal the class. And I'm going to inherit from network behavior. I'm going to remove all the default code except for the Unity Engine namespace. But now let's go ahead and add some SyncVars. So to add a SyncVar, first declare a field of any primitive type or fish networking supported type. I will show in the documentation what they are right now, but let's continue. Let's say I'm going to declare an integer. So I'm going to call it int, public int score. And I would like to have a player name as well. So public string username. Let's just call it username because mono behaviors already have a name property, okay? So usually two values like these are simply fields on an object. They cannot be synchronized over the network automatically. To do this, we go ahead and add the SyncVar attribute to the username field and a SyncVar attribute to the score field. Now what happens is, whenever the SyncVar value changes on the server, it will be automatically synchronized to the client, okay? If you haven't noticed, I said you need to change the value on the server, okay? Changing SyncVars on the client will never work, okay? So let's go ahead and demonstrate this. So I'm going to override a network callback called onStartClient. You should always call the base method first, okay? And call it, and never forget to like add it. It might seem like it doesn't do much, but it actually can cause like hidden bugs that can be very hard to track. So just keep that in mind. And I'm going to go down here and do an if is owner check. Let's negate this. What is owner means is if this object is owned by the local client's connection, then execute the following code. Otherwise, simply exit the function. Is owner check is very useful when you're trying to, of course, decide who's the owner of the object, or when you're trying to send RPCs from an object to the server, okay? So let's go down here, and let's say I would like to have each player set their name at the start of the game and synchronize it across the server. What can I do is call an RPC like this, server set name, and I'm going to give it a name, for example, like player, and let's say date and time .now .to, let's see, short string, for example. So this will simply display the player name with the current date in its short format, okay? Now you can see we have an error here, so let's go ahead and create our RPC. So private void server set name. I'm going to give it a string as a parameter. We're going to call it value, and I'm going to add the server RPC, okay? Now, since we got into RPCs now, let's explain what they are, because they are actually very simple and like there is not too much to learn about them. Basically, RPCs are remote procedure calls. They allow you to execute code from the client on the server, or from the server to the client. There are three types of RPCs in fish networking. A server RPC, which is an RPC that's sent from the client side to the server side, okay? An observer's RPC, which is an RPC that's sent from the server to all the clients or all the observers, okay? And a target RPC, that is an RPC that's sent from the server to a specific client connection, okay? All of them have their uses, and we'll explore them later. But now let's go to our server set name RPC and change our username and set it to the value, okay? Now let's save here. Let's remove the Unity engine namespace. Let's go inside Unity. Let's right click and create an empty game object and call it player. Let's add the player component, and I'm going to leave everything as default, and I'm going to drag the player prefab into my prefabs folder. I'm going to save, and I'm going to delete the player object in the scene. Now I'm going to go to network manager, and what the network manager is, it's basically as the name implies, what manages your transports, your client and server managers, your did I say transports? Yeah. So it's basically like a very important object, and you must always keep in mind like that it shouldn't be destroyed when you are switching scenes in a multiplayer game. Also, the network manager is very flexible and allows you to configure different stuff without having to add everything at once. So for example, if I enter play mode now, you will see that it added a bunch of new components, okay, like a scene manager, an observer manager, etc., and our tugboat transport. This is because whenever you don't add a component, the network manager will automatically add it using very good defaults, okay? So this saves you time from having to tweak everything whenever you're quickly prototyping or anything, okay? So I'm going to go now and add a component called the player spawner that will allow me to spawn my player object, okay? So let's go here and say player spawner and click here. So the player spawner component is simply a component that allows you to spawn a player object when the scene, when the server starts, or when the client connects, okay? In fish networking, you don't need to have a player object, okay? You can simply have connections and interact between them using broadcasts, but it's there for people that require it, okay? And we're gonna use it. So let's untick the add to default scene checkbox here, and let's drag the player prefab into the player prefab field, okay? Now if I enter play mode and click on host, you'll see that a player clone object has spawned and that its name is set to player 4th of May 2022, okay? Cool. Now let's go ahead and actually change that so it displays a more unique value. So let's say, what do we use for the name? Let's say, for example, random dot, let's do date and time again. Now let's get hash code. Yeah, so use the hash code instead of the string format. And now when we go and enter play mode and click on host, you'll see that we have a kind of unique value, okay? So to prove and to confirm that our SyncVars are working, let's do a quick build. Okay, so I have my build here. I'm going to enter the editor. I'm going to connect the console to the build. I'm going to go ahead and host inside the editor, and I'm going to connect from the client. Okay, as you can see, both our like the editor and the client have unique player names, and as you can see, the client's player name is synchronized correctly. And to, again, confirm this, let's disconnect the client and disconnect the server. Let's host in the client and let's connect from the editor. And as you can see now, the player name is synchronized, okay, here and there. So this is pretty much what SyncVars are. They allow you to synchronize values between the server and the client, okay? Let's go ahead and look at the on-change callbacks. Okay, excuse me. SyncVars can have what's called an on-change callback. Basically, it's a function that's executed on the server and the client when the SyncVar value changes. It's very useful for doing stuff like changing your character's color, changing your name labels, whatever in the game, without having to send RPCs and stuff, okay? How do we add an on-change callback? We go to our SyncVar attribute and add two parentheses, and then say onChange equals. Since you cannot reference functions directly, methods directly in attributes, we're going to use what's called the name of keyword. The name of keyword allows you to get the name of a symbol or a syntax node in C#, okay? So I'm going to have a little function here, a little method here, private void on username change, okay? And the signature needs to be like this. Whatever the type of your SyncVar, you need to say, in our case it's string, so we need to say string old value, string new value, and finally there is a boolean called is server. Okay, what all these parameters are, the old value is going to obviously be the old value that was assigned to the SyncVar. The new value is going to be the newly assigned value, and is server is going to tell us whether this function is being executed on the server or not, okay? So this is very, very useful when you, for example, want to send an RPC from the server when the SyncVar changes to the clients to notify them, okay? Or if you would like to execute logic only on certain clients and not the server, okay? They give you a lot of flexibility. And now, after we have added our method on user change, we're going to go here and say on username change. Some people might say that it's redundant that you use name of, but it's actually very useful. So for example, if I go ahead in Visual Studio and rename this function, let's say to onUserChange, you can see that its name updates here as well. And if I try and reference a missing function, it will give me, a missing method, it'll give me an error. So that's better than using raw strings because it prevents runtime errors by giving you a compile time one, okay? So now we have our onUsername change. Let's go ahead and add, for example, a debug.log, or instead let's add some labels and display our text in the game. Let's remove the score SyncVar. Let's add a reference to our text object, so serialized field, private text mesh pro, let's say name tag, and let's see, let's go inside Unity, let's right click and create, so let's drag our player object, let's enter the prefab, let's add a 3D object, text mesh pro, let's import all the essentials, and let's go ahead and change some text properties. I'm going to say 0.2, and zoom in, gate the scale on the x-axis, say name. I'm going to center my text, and I'm going to give it auto size, and let's maybe make the scale 0.5 on the x-axis and 0.5 on the y-axis. Let's go back into the scene and let's see. Our text doesn't show up. Interesting. So let's delete the player prefab and let's add it again, and now it shows up. Let's reset the scale. Okay. As you can see now, we have our name label here, and I'm going to go into Visual Studio, and inside my onUsername change, I would like to first have the name tag display only for the local player, okay? Sorry, for other players, not the local player, and I would like to update its value whenever it's changed. So let's go in and add an update function. So I'm going to say if not is owner, we return, and I'm going to say if inbit.getKeyDown kcode.g, like generate. We say server, set name, and maybe let's see, we're going to change it to some random string plus our client ID. So we're going to say layer random dot unity engine dot random dot, let's see, value dot get hash code, and then say plus client, sorry, owner ID. Okay. Now inside our onUserChange function, I'm going to go ahead and say if is owner. So is owner inside this check means that we would like to change, sorry, if not is owner. Okay. I would like to set the text to the newly assigned value. So I'm going to go ahead and say set, name tag dot text equals new value. Since our name tag is going to be displayed only for other players, we would like to update it only for other players. And now inside the not is owner check here, I'm going to go down and say name tag dot game object dot set active false. So if we are the owner, we simply disable the tag. Now I'm going to go ahead and simply include some extra info here in the player name. So plus is server, for example, so we can decide whether this is the server or not. This is actually going to be a long string, so let's just go ahead and say is server. So this just allows us to differentiate between the client and the server, okay? Let's go inside of Unity now. Let's open the prefab, assign the references, save, go back to our scene, and now we're just going to delete the object here, okay? Now let's make a quick build. Let's enter the console here and connect to the build. Let's enter play mode. Let's host the game here. As you can see, the text object has been disabled since we are not the owner. Sorry, since we are the owner. And now I'm going to go here in the client and I'm going to connect. And oh my god, the text is flipped. So let's go ahead and fix this. Yeah. Let's make a quick build again. Enter play mode, connect to the player, host, go to the client, connect, and that's it. As you can see now, the server and the client are connected and they show different names. Now inside my server here, I'm going to press G to change my name on the client. As you can see now, it sent a string to the server, which updated the SyncVar, and it added some extra info. So we have here the client, the owner ID is 0 since the server is actually the first client, okay? And we have plus true since it was called from the server. Now if I go in the client and press G, it will update on the server, as you can see here, and it shows client ID, owner ID 1, plus false since the client isn't the server, okay? So that's pretty much it for the SyncVars. As you saw, they are pretty easy to use and very easy to understand, and they are very, very flexible, okay? When to use SyncVars and when not to use them, okay? SyncVars are always useful for values that are constantly changing, like say, for example, a score, a let's see, what's a weapon stat, some experience, whatever a value is constantly changing, I suggest that you use a SyncVar, okay? What are the disadvantages of SyncVars, okay? Sometimes SyncVars, when you attempt to change them rapidly or multiple times in a single frame, values can actually, how do I say this? Race, you know? So let's say we send here, let's demonstrate this actually. How do we say? Let's say I send in my first RPC player name of player name 1, and at the same time another event or another code changes the player name to player name 1 different, for example. Now what would happen is whatever value was buffered last will be sent first and will be received on the client. So this can sometimes lead to values overriding each other's, okay? Overriding each other. So to fix this, you can use RPCs, okay? And in the next part of this live stream, we'll explain how to do this, okay? But that was pretty much it for SyncVars. Oh, we have a message from Wiglord, which says, I used SyncVars to handle outfits, equipment, meshes on players. That way, when the player loses later, then started the game, or switch it on and off due to observer conditions, it will display the correct visuals. Exactly. This is one of the very useful real world use cases by Wiglord here. Changing character outfits or visuals on characters. So that's one use case. And now, does anyone, before we move on, does anyone have any questions relating to SyncVars? Going to wait a little bit, so if anyone has any questions, go ahead. Okay, it seems that everything is clear. So let's go ahead and continue to the second part, which is RPCs. As I explained briefly last when we were doing SyncVars, RPCs are remote procedure calls. They are sent from either the client to the server, or from the server to the client, or from the server to a specific client. They allow you to do all kinds of amazing things and useful things, actually. Oh, wait, we have another message from Wiglord. Have to head home. No questions from me yet. Really enjoying the tutorial. Thank you, Wiglord, for showing up. Appreciate you showing up again. Thank you so much. Now let's go ahead and continue. As I was saying, SyncVars allow you to do all kinds of crazy things without complicating stuff, okay? They are basically methods decorated with the either server RPC, like we have here, or observers RPC, or target RPC, okay? Each of them have a use case, and we're going to demonstrate this right now. So let's remove all the code we have here. Let's go in Unity and let it compile. And now I would like to go ahead and add to my player a cube, for example. I'm going to remove the box collider, and I'm going to go back to my scene. I'm going to select the network manager. Going to add some spawn points so that when we connect, different players will show up at different positions. So spawn point 1 and spawn point 2. I'm going to move this to here and this one here. Now, when I enter play mode, I should hopefully get my player on the left side. Nope, yeah, because I forgot to assign them. So we add the first spawn point, then the second spawn point. Let's enter play mode now. And I should get my player on the left side. Yep, we do. Now let's go ahead and select the player and remove the text object. And now go back into the scenes. Let's go to the docs real quick and show you that RPCs have a very amazing documentation. As you can see here, it's very detailed, and pretty much it covers everything you need to know about RPCs, okay? I highly suggest always, even after watching tutorials or even reading the documentation multiple times, always read the docs. You can never get too much enough reading of the documentation, okay? You will always learn new things, or you will learn things that you might have missed the first time you read it. So always go back to the documentations. Please don't try to guess stuff, okay? Guessing will never work. Trying, reading, and experimenting will. Okay, so let's go in Unity now and open up our player script and begin. So I'd like to have it so my player can change its color. Okay, and sometimes I would like to have the player change the color locally only, and sometimes I would like to change it for all the players. We're going to use all three types of RPCs now. First, we're going to have a SyncVar, so serialized field, private, public color, color. We're going to say SyncVar. Here, so it's synchronized across the network. And the first way of changing the color we're going to be doing is first using a server RPC. So we're going to add a server RPC and call it private void server set color. Give it the color as a parameter. And inside it, I'm simply going to assign the color to, the value here. And inside my update function, which I'm going to write right now, I'm going to say if not is owner, return. And I'm going to say if input.get key down, keycode dot f, for example. I'm going to say server set color and pass it a random dot color HSV. Oh, this is inside the Unity namespace, so we need to remove this. So random dot color HSV, and I'm going to save. And I'm going to add a reference to my mesh renderer here. So serialize field, private mesh renderer, and oh yeah, let's name it mesh renderer so we don't have any name conflicts. And now I'm going to add a SyncVar hook. So private void on color change, color old value, color new value, and bool is server. Now I would like it to change for all players. So we're going to simply say mesh renderer dot material dot color equals new value. Now when I exit here, and before we continue, I would like to change this so it's not using random colors. I would like it to switch between red and blue, just to make it clear that we are actually changing it. So I'm going to change this to alpha 1. So when we press the 1 key on our keyboard, it'll set our color to color.red. And if we press alpha 2, which is 2 on the keyboard, we're going to set it to green. Okay. Now I'm going to save, go into Unity and let it compile. I'm going to select my player object here. I'm going to drag my cube as the renderer, and I'm going to leave everything else as default. Now when I save and go back, I'm going to make a quick build. I'm going to go in the editor now. I'm going to go to the console, select the editor, select the desktop, and then enter play mode. And on my client, on my player, I'm going to host. And in the editor, I'm going to simply connect as a client. Now I'm inside my player, and when I press 1, nothing seems to happen. But the color is changing as expected. Interesting. So yeah, that really didn't work for some reason. We will see why. So we're assigning the new value here. We are getting the material and the color. Very interesting. And this is a server RPC and everything is fine. So let's check in the editor when we host. The color doesn't change for some reason. Let's select the default material. Maybe because the material is a built-in one. So let's actually create a new material. I'm going to call it player. It's going to be a simple standard material. I select my player and I'm going to add the player material to it. Go to scene 1, enter play mode, host, and still doesn't work for some reason. This is actually very interesting. Oh, chat, you should have let me know. I didn't add the hook here. Name of on color change. Okay. So now when we go into Unity and enter play mode and host the game, when I click on my alpha 1 and alpha 2 keys, you'll see that the values are changing. And as you can see here, it is working correctly. Now let's make a quick build. And I'm going to go in here, going to connect to the player, enter play mode. I'm going to host in my client, and I'm going to connect from my editor. And now when I press 1 on the keyboard, you will see that the host changes to red and it's synchronized across the network. And I'm going to go in the editor and change to green, and you'll see that it did change, in fact. Now, if I can keep changing it constantly, and it will work just fine. So I'm going to set the host here to green, and I'm going to set the client here to red, and you can see that it is synchronizing correctly. Okay. Now this is fine, and it works fine. Now I'm going to go ahead and show you another way of doing this. Now that we explained server RPCs, I'm going to use observers RPCs. Okay. Now let's remove our onChange function here. Okay, we're going to keep the SyncVar though. Or let's actually not use SyncVars. I'm going to simply show you how to do this with normal fields. Let's remove this. Let's actually keep this in case we need it. And I'm going to have observers RPC, private void observers set color. I'm going to give it the color and pass it as a value as well. So an observers RPC, as explained before, is an RPC that executes from the server on the client. Okay, it allows you to change stuff locally on each client, and it's very useful. In this case, we're going to use it and a server RPC as an alternative, and in my opinion, a better alternative to SyncVars in this case. So I'm going to go ahead and inside here, going to remove this. And I'm going to, actually no, going to change the color here first, and I'm going to say observers set color and send our color as the color to the clients. And I'm going to say color, so we assign the color on the client now, equals the value, and mesh renderer dot material dot color equals the color. Okay, now when we go in the editor, when I enter play mode, click host, when I press 1, it indeed changes the value and changes the color. Now let's go ahead and do a quick build. Let's go in the editor. Let's connect the console. We have a message from Brandon Anderson. I am Emilius, by the way. Oh, welcome to the stream. I didn't actually know this, so that's good to know. Let's go in the play mode. And now, when I host in the client and connect from the editor, when I press 1, you'll see that the colors are indeed changing. And let's do it from the client side. We'll see that it is working as well. So, what's the advantage of doing this? Synchronizing values using RPCs has the advantage of actually avoiding what I mentioned before about the values racing. Let's basically call it race conditions. So as I mentioned, in this way, when you send multiple callbacks or send multiple callbacks from different places at the same time, they will all be buffered, and the last one will be executed. So this ensures that the correct value is sent. Okay, but this approach, like we are doing right now, has one big disadvantage, and that is if I stop the connection from the editor, which is the client, then connect again. Wait a second. Oh yeah, stop and connect again. You'll see that even though I have the client, the host red here, it doesn't show up on the client. Why is that? Because the values are not buffered. You might ask, what's buffering? Buffering is simply, in the context of our networking solution Fishnet here, is the act of storing the last value sent in an RPC so that late joiners or clients that join the game later can see the correct value. You might ask, oh, this sounds so, you might say this sounds so complicated, how can I do this? It's actually a matter of adding a single value, a single attribute field. So let's actually exit the player, exit play mode, go in Visual Studio and go to our observers RPC here, and I'm going to say buffer last equals true. You're going to say this is too good to be true, but it's actually that's good and it is true. Okay, let's go in Unity Editor and let's do a quick build. I'm going to use the editor as the client and the player as the host. So now let's go ahead and actually, before we join from the client side, let's change the color to red here. Okay, and let's connect, and you'll see that the value is indeed synced. Now let's change it, and as you can see, I keep changing it from red to green. And now if I disconnect, connect again, sorry, you'll see that the value is synced correctly. The reason this cube shows here sometimes is because the spawn positions simply loop around. So yeah, but as you can see, it works correctly, and I can synchronize values in a more reliable way, okay, using observer RPCs. When not to use observer RPCs as SyncVars is always, okay? Let me explain. RPCs are lightweight and everything, but they have their uses, and SyncVars have their uses, okay? When you find yourself changing a value constantly, simply use a SyncVar, since, as I mentioned before, it's buffered and all the updates are sent as one at the end of the frame. So this is better for bandwidth and game performance, so that you don't clog up the network and the game simply disconnect or anything. Of course, fish networking has protection against this, so I doubt it will happen, but it's just something to keep in mind, okay? Now let's exit play mode and exit the player. Let's go into Visual Studio, and let's do one last thing. As you saw here, we used observer RPCs to change the color on all clients. Sorry, I had to go for a second there. We used the observer RPCs to sync the value across the network and to all clients. But what if we have something that needs to be done only for a specific connection, okay, or only for a specific client? You can use an observer RPC and do an isOwner check, but this is like a waste of time and performance, because it's still sent to everyone and you do the check on all the clients, so that's not very good. Instead, we have something called the target RPC. A target RPC is simply a remote procedure call, but it's, instead of being sent to all clients, it's sent from the server to a specific client or connection. Okay, so I'm going to have one here and say target set color, and I'm going to say color value. I'm going to say color equals value, and mesh renderer dot material dot color equals value. Okay, now I'm going to simply have a boolean here. I'm going to say bool change for owner only, and we're going to set it to false by default. And I'm going to, inside my server RPC here, check if change for owner only. We say target RPC set color, but there is one problem I forgot to mention here. When you declare target RPC, you need to specify a parameter called network connection, which is the connection that will be sent, the RPC will be sent to. Okay, you don't need to reference it anywhere in the body, just be sure to include it. Okay, so here I'm going to send the RPC to my owner, which is a network connection, as you can see here, and it is the connection that owns this object. And I'm going to send my color. Otherwise, I'm going to simply do the old approach and use an observer's RPC. Now, when I go inside of Unity, everything did compile already, which is sweet. Now let's Control B to build. And now let's go to the console here, connect to the player, enter play mode, go to the player and host. Then I'm going to connect from the editor here. There is actually one thing, and this is very dumb. I actually forgot to add the checks to send the target or observers here. So I'm going to say if alpha1, we're going to simply say if input.get key down key code dot alpha dot left control. So now whenever I am pressing left control and alpha1, it will send the RPC as a target RPC. Otherwise it will send it as a observers RPC. Okay, but this isn't very reliable, so let's actually remove it and go down and add a couple of extra checks. Not a big deal. So alpha 3 and alpha 4, and we're going to send these as target RPCs. Now let's go in the editor here, and let's go ahead and control B to build. Going to enter play mode here, and I'm going to host in the player and then connect from the editor. Now when I press 1 and 2 normally on each one, you'll see that the values synchronize between them. But if I go ahead and press 3, for example, you'll see that it's sent only to the local connection. And I'm changing my color from red to green only on this player instance. Now, when I go in the editor and do the same, you'll see that it doesn't send it between clients. This is very, very useful and very, very, how do I say this? Yeah, it's just, I don't have any other word. It's very useful and convenient, so you don't have to do any checks or any iterations or stuff. You simply send it to the connection you would like to perform the action on. Okay, so when to use target RPCs? You can use target RPCs when you are, for example, showing a specific piece of UI on a specific client, or would like to give or spawn an object. Sorry, not that. This is actually wrong. If you would like to, for example, change the color of something on the client, change visuals, spawn particles on the client, only, like that. And when to use observer RPCs is like we demonstrated before. If you would like to synchronize values or execute something on all the clients with only minimal difference, So yeah, that's pretty much it for RPCs. Okay. Does anyone so far have any questions relating to RPCs or SyncVars? I'm going to wait a minute before I move on, so you can ask any question you would like to. We have a question from Ed Tango. Could you elaborate more on what you meant by saying this when not to use observer RPCs or SyncVars always? Yeah. I didn't actually mean to word it like this. Actually, English isn't my first language, which is obvious, but let me explain. When not to use observer RPCs or SyncVars, always is like, I need to explain this in more detail. So yeah, let me gather myself up. I meant not to use observer RPCs as SyncVars, if that's what you mean. Yeah, don't always use observer RPCs as SyncVars, okay? Only use them when you require the values to be like exact and synced correctly and without any races between values. That's when you should use an observer RPC as a SyncVar. A SyncVar should be used when you would like to sync values between the client and the server, and you don't care so much about its accuracy, okay? Like, for example, the number of pickups, which is an integer, which will always remain the same, or something like a score that can be reset when the player dies, whatever. So yeah, is that what you meant? If not, please tell me so I can explain more or correct what I said wrong. Okay, that clears it up. Yeah, okay. So that was it for RPCs, and I'm now going to move to broadcasts. So let's exit the editor, play mode, go to our player script, and let's remove everything inside of it. And let's go ahead and remove the namespaces, and let's go ahead in the editor and let it compile, and finally go to the docs. Let's go to the broadcast section, and let's see. Before I continue, like I said before, always read the docs, okay? As you can see, we have very decent documentation on broadcasts. It might seem like it's not enough, but it's actually all you need to know about RPCs, actually, okay? Sorry, about broadcasts, actually. There is nothing else to know. This is how you send and receive them, okay? This is also how you register and unregister them, okay? So let's go ahead and begin writing our own. Okay, in the editor now, what the heck is this? Give me 1 second, please. The stream chat is glitching for some reason. Okay, we're back. Now, when to use broadcasts? Broadcasts are a lighter version of RPCs. How light, or like in what way they are light, you might ask? They simply are not tied to any game objects or objects in general, okay? They can be sent between connections from the server to any client connection, or from any client connection to the server, okay? You use messages or broadcasts, sorry, to send data along with them to the server or the client, as mentioned before, and you perform actions based on what you receive, okay? So let's go ahead and do an example of this. So I'm going to go ahead and change my player from being a network object to be a normal mono behavior, okay? And I'm going to go ahead and add a serialized field, private mesh renderer. I'm going to also add a color field, so private serialized field color. Okay, now if I might want to synchronize or change the value of these, even though they are mono behaviors, on the client and the server. It could be sometimes difficult to do this. You might do some very crazy workarounds and say, I must have an object to send stuff like this, but no, you can use broadcasts. Now let's go in Unity. I'm going to go to my player, going to remove the network object component, and I'm going to go to my scene, go to the network manager, remove the player spawner, because I'm going to demonstrate that we don't need a player object to use fish networking or to actually synchronize stuff. And I'm going to place my player object here. Let's say I would like the client and the server to change its values, okay? So I'm going to go ahead and create a new script, or simply let's go to the player script, and let's begin writing our broadcast data, okay? So we're going to have a public read-only struct, and I'm going to call it change color broadcast, and I'm going to inherit from the iBroadcast interface, okay? So let me explain this line of code here. A struct is what C# calls a value type. It's simply it's stored on the stack instead of the heap, so it's a little faster, but it has value semantics, so it's copied on assignment and not referenced, okay? What this means is, if I go ahead, for example, and say color equals color.red, the red color isn't simply referenced by the color field here, no, it's actually copied by value to it. So you can use structs whenever you are trying to store primitive data like strings, integers, and stuff like this, and would like to pass them together as one, as a bundle. You can use structs, okay? Otherwise, usually you would use objects, but in our case here, fish networking only allows broadcasts to be, as far as I know, structs. And the reason I made it read-only is that you should always make your value types or structs read-only. Mutable structs is a source of all evil. You will find this quote everywhere online. and it is very true, okay? Because when you change the value of a struct field, you might accidentally copy the struct beforehand, or you might assign it a value that mutates it, and this usually has some very crazy side effects. So always try to make your structs read-only. Okay, so now here I'm going to go ahead and say public color new color, and I'm going to go ahead and add a constructor. Oh yeah, it needs to be read-only, yeah, as I mentioned before. And as you can see here, I have a very simple constructor that assigns a new color to the new color field here. And then I'm going to go down here in my player, and I'm going to begin registering the the broadcasts, okay? In our case, you need to register the broadcast, whether on the server, either on the server or on the client, or both. You can have handlers that execute it on the server and handlers that execute it on the client. So let's go here to let's override on start. Oh, excuse me. Let's go to the and add the start function. And inside the start function, I'm going to say instance finder dot client manager dot register broadcast. So it's going to register a handler for the broadcast of the type change color broadcast, okay? And it's going to register a function to it. So let's go ahead and create one down here. We're going to say private void on server send color change, because as you might have noticed, when the client manager registers a broadcast, it registers a receiver or a handler function that when it receives the broadcast from the server, okay? So I'm going to have change color broadcast as the arguments, and I'm going to on server change color here. Inside this, I'm going to say new color, color equals arguments dot new color, and mesh renderer dot material dot color equals color, okay? Now instead of using on start, actually let's use on enable, and go and add on disable as well, so that when the object is destroyed or disabled, we don't need to handle the broadcasts. And we do like we see here, unregistered broadcast, pass it the type of our broadcast, and what the heck? We remove the handler from the broadcast handlers, okay? Now let's go ahead and see here. Where is it? I'm missing something here. 1 second, please. We have everything in place, I assume. Yeah. Yeah, let's add our update function so you can send and receive the RPCs. Now we're going to have a single object, our player object here, that will send and receive the RPCs both on the server and on the client, okay? To do this, let's go ahead and say if is server. Instead, we're going to say instance finder.sServer, since we do not inherit from mono network behavior. And we're going to say else if we are the client. So if we are the server, we're going to say instance finder dot server manager dot broadcast. Okay, what this means is the server will send the broadcast to the clients. Okay, so as you can see here, you can specify the type of the message, but since C# can automatically infer the type from the parameters, so if I say new change color broadcast and give it like a color red, it'll automatically deduce that we are trying to send a broadcast of the type change color. Okay, you can also send to a specific connection, as you can see here, and this overload here. You can send to a specific connection, but in our case, I would like to send it to all clients. Now, let's go ahead and test this. So I'm going to save. I'm going to go in Unity. Oh, big mistake. I need to add an input check. So say if input dot get key down, key code dot c. Going to move all this inside. I'm going to go in Unity now and enter play mode. I'm going to host, and when I press C, you can see that the color has indeed changed. Okay, and I'm going to exit this, and I'm going to now go ahead and build our player. Let's enter play mode here. And let's host in the player and connect from the client. And when I press C, you'll see that the color has synced. And you can see that the field is set correctly. Now, when I try to send it here, nothing will happen since the editor is the client and we haven't yet implemented this. But as you can see here, I did change the value to be the red color and it did synchronize. Now, let's exit this and exit play mode. We get this error simply because we are trying to unsubscribe from the client manager when it's getting destroyed. This usually, you need to simply add an instance finder.network manager null check here. But since this error doesn't affect us, I'm just going to leave it right now. Okay. Now let's implement the server versions of these functions here. Okay. Now let's go ahead and say instance finder. That's actually before these. See instance finder server manager register broadcast. I'm going to say color change color broadcast, and I'm going to say on client request color change. Okay, and I'm going to add this here as well. And I'm going to say unregister, and here I'm going to copy this and paste it down here. Say client request, and we need to add a connection parameter here. So network connection. This parameter here is insanely useful because it allows you to decide, like it lets you know which client sent the broadcast. This can come in very, very handy on you'll find yourself always using it sometimes, okay, to send messages back to the clients. So let's say you would like to have a request and response system so that you send from a client to the server, and then you reply from the server to that specific client with a specific piece of data. Okay, so this parameter is insanely useful. I use it all the time in my projects. So yeah, let's go ahead and continue. Now, when we receive this message from the client, we're going to reply back to that client and change the color on the client. Okay. But since I don't want to send to that client only, so I'm going to send to all clients again. So I'm going to do this by saying instance finder dot server manager dot broadcast change color broadcast. Actually, don't need this, as I mentioned before. Create a new change color broadcast, and this time I'm going to say color dot green. Okay, so when we request to change the color, the server will send the green color, and when we send from the server directly, it will be red. Okay, and inside the client is client check here. You can say instance finder dot client manager dot broadcast new color change, and I'm going to send, let's make it green and use the arguments that the client sent as well. Okay, so let's do a quick check here. Let's remove unnecessary code, and it's pretty much it. So let's go in the editor. Let's clean the console. Let's do a quick build. And now we're going to host here, and we're going to connect from the editor. And let me see which key, yeah, C. So when we press C on the host, we'll get the red color. When we press C on the client, we'll get the green color. And as you can see, the value has been synchronized correctly. But one bad approach to this is that, unfortunately, unless you implement it yourself, broadcasts are not, how do I say this, buffered, okay? So if I disconnect, okay, let's stop the connection, please. And yeah, and change the color to red and connect back again, we'll see that the value didn't change. But when we change it again, you'll see that it does sync. You can, of course, have your own buffering system or your own queue system that you can use to send messages to the clients when they join again with the latest data on the server. But since this is quite a complex topic, I'm not going to cover it in the stream, maybe a future one. Let me know if you would like to see something like this, okay? So that pretty much sums it up for broadcasts. Broadcasts, as I demonstrated, are very powerful for synchronizing stuff between the server and the client without relying on network objects or network behaviors, okay? So before I move on, does anyone have any questions relating to broadcasts, RPCs, or SyncVars? Going to wait a bit before I continue on.